Hello everyone, and welcome to this workshop tutorial, where today we are going to learn how to create an NFT collection using the Luxor standard LSP7 or LSP8. So in today's video, we're gonna see how we can create different type of NFTs, and we'll see different example. For instance, like the example that you have listed here, to create different type of collections. So things like NFTs where you need to create large quantities, like digital tickets for events, or large quantities of NFT with the same design that act as collectible, or using or doing things like creating a collection like a basic NFT collections or dynamic NFTs that can evolve, or a more advanced use case like collections of sub-collections. So to get started, we are going to use a template that I've created that use the latest version at the current time of Hardhat and Ethers, and so you can run the following instruction to clone the repository and install all the dependencies. And you need to make sure that you have this version of Node.js. And if you don't, you can just install it using, you can just update your Node version using NVM. Okay, so let's get started. So first of all, we need to, and there is a first concept that we need to learn and understand, which is the type of token that we are going to create. So the type of digital asset. And when we create a digital asset smart contract on Luxor, we need to specify the token type under the following data key in the ERC75Y storage. So there are three types that we can define. We can define either a token, or we can define an NFT, or we can define a collection. A token will mean that each item have the same value as another. An NFT will mean that each item are unique with our own design, and a collection will mean that it's a group of NFTs. Okay, so let's get started. So we're gonna first start by creating a digital ticket for an event. And to do that, we can use the standard LSP7 and set the decimals to 0 using the non-divisible flag when we deploy the token. And so the token type would be 0, which is a token. And this is useful when we want to create large quantities of NFTs where each NFT is the same. And we can use that especially in context where we need to mint large quantities of NFTs all at once. And thanks to LSP7 set to non-divisible, we can do that because we will be able to create, to call the mint function once with the recipient amount, the recipient and the amount of token to mint, to create. And then we will just call the, this will just create the whole batch all at once. So for creating, this is useful. Because we can just do that in a single transaction instead of calling mint and the token ID 1,000 times. So a good example of use case for that are cinema tickets, things like event tickets for events, or where we want to supply the total amount that we want to create, and then we can afterwards transfer each of them individually, or each attendant to the event can basically claim the NFT. So this is an example of how we can represent an event ticket as an NFT using LSP7. So as you can see, we will just inherit the LSP7 mintable contract, and we just define the name of the event, the symbol of the token, and who owns the contract. We mark this contract as non-divisible, meaning that when you get a digital ticket for the event, it's a full ticket. You cannot split the token in the ticket in half, which is the parameter non-divisible here. And then we can set the token type, as we said, for LSP4 token type, to a token, meaning that what we are creating represents an actual token. So one ticket has the same value as another ticket. They are all both interchangeable. And we can mint a batch of 1,000 tickets, of 100 tickets here all at once, as follow. And we are using here the traditional distribution, the pattern that is often used, where basically tokens are just minted to one address that will then distribute these tickets. Okay, now we're going to see the second example, where we can use still the same standard LSP7 to create 100 collectibles with the same design. And so it will be the same, we just use LSP7 set to non-divisible, and the token type is 1. And this is useful when we actually want to differentiate, when we want to create large quantities of NFTs efficiently, but we want to differentiate if the asset we are creating is either a token or an NFT. So in this case, here all the NFTs have the same design. It's still useful to issue large quantities, and a comparison with the real world here is Pokemon is like basically trading cards. If you're familiar with trading cards, a lot of people collect them. Things like Pokemon or Magic the Gathering or baseball cards, and there are multiple quantity of such cards. For instance, a Charizard or one of a baseball card like that. They have been created in multiple quantities, but people collect them, have a collectible aspect. So this is how we can use the standard to map to an example from the real world. And this is how that would look like in Solidity. We will still use LSP7, so we can create a large quantity, but the only we set the non-divisible flag to true, because it's the same. A trading card, you cannot rip it in half and give me half. You just own the full card, or you don't own any card, or you don't own the card. And same, you can see here in the constructor, we're going to set the LSP4 token type to be an NFT. Okay, now we're going to see a third example where we are going to create a collection where each collectible is unique. And this is a bit similar to what already exists. And to do that, we are going to use LSP8, and we will set the token type to a collection. And this is the most simple way to create NFTs on Luxor, really, that mimics the current NFT collection that exists. So if you want to recreate popular collections similar to what's already there, like out there, like CryptoPunks or Bored Apes, collections like that, you can use this mixing of LSP8 and the token type to 3. And yeah, this is useful, especially when you want to create an NFT where the metadata is going to be set in stone. It's not going to change. And so, like, you create the NFT, you set its metadata, and the metadata is set up. And a very relatively speaking example with a real world again is it's basically painting or digital art. You basically create when a painting is created, it's the art pieces is there. It's not going to change. It's just painting and in oil painting, and we have the same nowadays with digital art. So, for instance, this collection of digital art, the art piece is there. It's not gonna change. So yeah, we can use this combination to reproduce something similar. Okay, so we're going to do a bit of coding in Solidity, and we're going to see how we can create such a basic example. And we'll do that by inheriting the LSP8 contract. So I will go over the repository. If you have downloaded it and you have installed it, you will see that it's a playground file that we're going to use to create our collection. And you just need to install the package with Yarn if you haven't done it yet. And what we're going to do is we are going to create our contract, or NFT collection contract. So let's call it Digital Art Collection. And in order to make it as an NFT, we are going to import the LSP8 identifiable asset contract, and we are going to import it from the Loxo smart contract package, which is here. So you have to specify contracts, you have to specify LSP8, and we are going to take this one. Okay, so we're going to take this one and we are going to add it into the inheritance. And here we will write the logic code here. Okay, so as you can see here, if you try to compile the contract, and if you run npm run build, which is the command for compiling, you will get a first error from the Solidity compiler saying that we have no argument that have been passed to the constructor. And the reason is that LSP8 expect to take arguments on deployment. So we're going to see in a minute now these arguments. So when you deploy an LSP8, an NFT contract on Loxo, you have to specify the following. You have to specify the name of the token. So in this sense, in the context of this tutorial, the name of a collection, the symbol, who owns the NFT contract, who controls this contract. So this address is basically going to be the one that can set all the metadata inside the contract, and in the future, if this contract needs to be owned by someone else, for instance, the whole let's say in a real world context, the whole management of a collection is moved to like an organization or another person, then this is the address specified as the owner that will be able to do that. And finally, we will have to define the type of NFTs and token IDs, and we will see that in a second. So it's technically two ways in Solidity here to define that. We can either use predefined deployment values, so we hardcode that in the Solidity code, or we can specify the values in the JS and TS JavaScript or TypeScript. So the first method is useful when you know already what's going to be the name of a collection. So you don't have to write the code in JavaScript and deploy like that. You just can hardcode everything into the contract, and it's just going to be easier. It's going to be a bit cheaper to deploy because the things are not, the arguments do not need to be parsed and extracted from the call data. And the second method is good when you are creating something more like a template, a contract template that can be reused to recreate NFTs collection. Okay, so to give an example in form of code, the method one is like that. You just specify the argument as literal values inside the inheritance, or the second method is you define a constructor and you will write the arguments as parameter, and then you will specify the arguments in your JavaScript code like this. So this is an example with ethers and type chain for deploying the NFT collection. So I'm gonna just carry on the code here. So in my case, what I'm gonna do is that I'm gonna do method one. I'm just gonna create I'm just gonna write it down because I kind of have an idea of what kind of digital art collection I'm gonna create. I'm gonna create a collection of 3D, let's call it 3D artistic cube. I'm just going to create, basically, let's imagine we are creating different cubes as digital art painting with different shapes and colors, and this will be our NFT collection. So this is the collection name. The symbol, we are going to say 3D cube. So this is what will appear in the block explorer under the name, under the address. The owner is going to be I'm going to specify the address that will deploy the contract, and then we'll have to specify as well the token ID type. So for the owner, you can basically, if you look at the contract here, if you look at the contract, we can basically go into let's look at the actual contract code. So the owner here is basically the address that you create the contract, and the fourth will be the token ID type. We're going to specify that in a minute. If you want, what you can do is that you can also, if you know an address that will deploy if you know the address that will own, that you will own the NFT collection. So for instance, you want to use one address to deploy the contract and another address to specify as who will have control over it. You can just specify like this as a constant both. You can just say LSP8 collection owner, and here as an example, and I will just say if this, and you can just specify the you can just basically specify the address here. Yeah, it's just gonna ask me to check the address. So you could have like put the address here to specify. So you just can basically do that. This will be the contract that owns this. Okay, now we need to look at this parameter, the token ID type. So what is it? So basically, when you specify, when you create an LSP8 collection, you have a parameter that you need to specify, which is the LSP8 token ID type. And the LSP8 token ID type is basically what you're going to use to define how the identifier of each NFT will be represented. So with LSP4 token type, you specify how you have to interpret the assets inside the contract. With LSP8 token ID type, this is really for NFTs. This is for specifying which method you are going to use to create the identifiers for each NFTs. And so in the LSP8 standard, we have 5 ways to define to do that. We can I'm going to go through the main 3 here, and then we will have another future example for the last one. So let's give the first example. We can first use the token ID type 0, which is basically a unique number. And you can use that for things like you start at token ID 1 and you increment as you mint new NFTs. And a popular example that exists out there is basically the CryptoPunk collection. The token IDs started at 1 and then they got incremented. There has been 10,000 CryptoPunk that got created, and each CryptoPunk has the identifier 1, 2, 3, 4, 5, and that increments as it goes. A second example for token ID type string is we can reuse the example that we had, and this is useful for when you actually want to say the identifier of the token ID is going to be a whole name string. And to use our example of digital art, this is useful because this token ID type is useful for this purpose. Because if you create let's say digital art and you call one painting here XML file 9853. This is easier to identify the token ID like that. And yeah, and or if you let's say you if you create the digital Joconde, you will basically, let's say you recreate the digital version of popular painting. You can say you can name the token ID the digital Joconde, like the famous painting of Da Vinci. It's easier to identify the digital piece of art by its name rather by an identifier that doesn't properly match. So depending on the use case, the token ID type is easier. It is easier for identifying an NFT. And so here in this case, each digital piece of art is represented by its name. Another use of the token ID type, for instance, is the number 2, which can be used for things like a really unique and specific ID. And let's say, for instance, you have a physical good in the real world that you want to map on the blockchain with something like an NFC chip or a QR code. Such good can have a serial number. For instance, you can have a collection of Rolex watches, and they have all their unique serial number. And if you want to map that onto the smart contract collection for the Rolex collection, you can use this token ID type, where the token ID is the serial number of the item. And we can import all these token ID in Solidity as follows. They are defined in the LSP8 smart contract. And in our case, we are going to use the token ID type number. So let's carry on into our playground. We're just gonna, so I had put a 0 just for silencing the compiler warning. So we're just going to specify, we're just going to import that. So we're going to say underscore LSP8 token ID type number. I'm going to use the more simple one. And I'm going to do LSP smart contract, and here I'm gonna go here again, and I'm gonna specify LSP8 constant.so, and I will pass this argument here. Or in the case of a painting, we could say string, because it's more appropriate with what we were using before. Okay, so now that we have created our first basis for our NFT contract, we have still one problem, is that we have no public method for minting new NFTs. So we need, and the reason is that the LSP8 contract by itself doesn't have this, because every contract creator will define its own way to mint and create new NFTs. So we have two methods. It's either we create our own function to create our own NFT supply, or we basically use our preset. So the first method will be to create your own function. In this case, we will call it, let's say, create new cube, and so we could call it, let's say, create new cube, and we say cube name, address, recipient, and we will have our public method. We make it only owner, so that only the contract owner can create a cube. And then we need to define the token ID, and we basically have to parse. So we need to parse the name of the cube as bytes. So the token IDs are bytes 32, so we need to parse the token ID as bytes, and then we need to parse the bytes as a byte 32. So we have our token ID, and then we can call the internal mint function, and as you can see, it's going to take the recipient, the ID of the token ID, the force parameter, and the data. So the recipient, we have it in the function parameter. Then we're going to specify true, and then the data. And then the data, so we're going to just specify no data. This is basically any extra data that we want to send when we notify the recipient that we have created a new NFT, that he has received a new NFT. Yeah, so here I will not put anything. And the force here, the true parameter, is basically the parameter called force. This is for enforcing. This is for basically ensuring if we are transferring an NFT to an address that cannot handle the NFT or not. So in the Luxo ecosystem, basically the recipient have to be smart contract of tokens, have to be smart contract that implement the LSP1 standard, the LSP1 universal receiver standard. And this is to ensure that they can handle and register and unregister these tokens. So if you specify, by default, it's if you specify false, if you are sending the minting or transferring the NFT to an externally owned account or a smart contract that doesn't implement LSP1, this will fail. In this case, we're just going to put true to just mint for anyone, a universal profile contract that implement LSP1, or any smart contract or any EOA. So one syntax that I like to write in general, it's basically writing the name parameter so that it's very clear what everything mean. And you can do that in Solidity as follow. You can just basically take each of these parameters and this is basically the name parameter way to call a function. So this is clear what each parameter means here. But in our case, we are not really going to do that. We're just gonna create a public function called. In our case, so this is the first method, and the second method is you can use a preset contract that we have, which is called LSP8 mintable, and you can narrate it here. And when you have, so I will just comment out this method, and when you use LSP8 mintable, what happened is basically the following. You have a public method added into the API that you can call to create your NFT collection. So if we look here, if we look for mint, we'll see we have a public mint function here in the API that take all these parameters. It takes the token ID. Yeah, so basically we created here two ways to create NFTs. So now that we have created the NFT, what we can do is that we can specify the metadata URL for each NFT. And the most simple way is to basically have all the metadata of each NFT, the links that reside in the contract. And you can do this by setting the base URI the base URI under this data key, and then to get the metadata of each NFT, you then append, extract this base URI and you append the token ID. And what this parameter takes is basically it's the hash function, it's the verifiability, and this is the base, and this is the constant for verifiability, and this is the base URI that you will use. An example of how we can use it for this is for board apes. Basically, board apes, for metadata, they all have the same base URI, and the metadata never change. So they just all have their base URI, and there is the token ID appended at the end. Yeah, so if we look carefully here, basically this is the example in JavaScript where we do that. And yeah, as I say, under the LSP8 token metadata base URI, we have a tuple that we had defined here. And the first value is the first 4 bytes of a hash of a word getChat256 parentheses with UTF-8 in parentheses. This is the hash of that. And this is used for verifiability, to ensure that when we create the JSON the URL to the metadata, it's verifiable. And then we have the base URI appended at the end. Okay, the fourth example is for dynamic NFTs, NFTs that can change their traits and attributes over time. So in this case, the combination that we will use is LSP8 plus the number 3 for the token type, meaning we are going to create a collection. So when we do that, each token ID here is an NFT that can be its own smart contract. And for example, a contract, an ERC725Y smart contract, and it can have an infinite amount of entries as data keys to specify specific attributes. And this is very useful if you want to create an NFT collection where the attribute of the NFT can change. So you can create basically digital items or entities as NFT that can evolve. And this is useful for things like NFT that you want to make customizable. So basically the user owns an NFT that is specific to him, but it can also even customize it. Or things like some use cases are like characters in a video game that can evolve as the character by equipment, weapons. So for instance, this is an example from a famous video game, Assassin's Creed, where the character can upgrade and downgrade and change his equipment, like his helmet, his weapon, his uniform, and you can technically store all of these under the ERC725Y storage of a contract that represents the NFT. So to do that, what we do is that we inherit LSP8, and we use the token ID type address, and we will set the token type data key to collection. And so this is the whole collection that contains all each NFT identifier, and this is the contract that will be for the actual NFT itself with the metadata that it contains. And this contract basically here specifies the owner of an NFT and the collection that it belongs to. And this collection can be specified under the LSP8 reference contract data key. So this way you can point backwards to when you query this NFT as a smart contract, you can know from which collection it comes from. You can go from both ways. You can basically check under this contract who owns which NFT, and the token ID will be at the address of this contract. And in this contract, the value stored under the LSP8 reference contract will be the address that this contract belongs to. Okay, and the final example, which is the most complex of all of them, is that you can use LSP8 and LSP7 in multiple combination to create a collection of sub-collections. So this is a very advanced use case. So the standard will be still LSP8 and the token type will be still free as a collection. And in this case, the LSP8 contract is actually a whole collection. It's really it lists all the sub collection that it contains. And each token ID is actually another smart contract that is an LSP7 contract that is still non-divisible, and this represents one part of a sub collection. And a good example, which is quite common to anyone in the crypto space, is to create the famous sticker that we all collect when we go to crypto events, but in a digital form. So if you go to a crypto event, you will see that at any booth, everyone has a whole set of stickers. And there is different design for each stickers, but there is multiple of them. And at Luxo, the stickers that were very popular are the Luxo Good sticker, the Luxo Super Good, and the one in whole silver. So basically, each sticker, what happens here is that this is the whole LSP8 contract, and each of these stickers is actually an LSP7 contract with a certain number of digital stickers that exist. So will be one LSP7 contract, this will be another one, and this will be another one. And there will be a limited number of each sticker. So I've represented with a different example here, where you have the NFT contract, LSP8, that contains all the list of stickers, digital stickers created. So all these digital stickers are basically NFTs. So this is the whole collection. And the token ID type is addressed because each sticker is a smart contract. It's an LSP7. So the token ID for 16A4F, it's basically the address of an LSP7 contract that has the silver dog sticker. And you have that for each basically sticker. And in this way, you can create things like a collection of sub-collections where each sub-collection has a limited number of items available. So for instance, in this case, the sticker, the silver shiny dog, has there is a lot of quantity available, and the second one here is a bit less common, while the last one, the 6-eyed cat, it's very rare. There is only 5,000 digital stickers ever created, and still each of these tokens are non-divisible. So you can use this approach also to create a collection with a sub-collection inside them that where each item is more scarce than others. And yeah, this is basically how you can compose the different LSP standards to create different type of NFT collection as you want. And the example here will be that in the form of code snippet, that will be the following. You have it's better viewed in VS Code, where you have here you have the whole NFT collection. So this is the LSP8 contract. When you deploy it, you specify the LSP4 token type, and you can technically this is a pseudo example where you create a new sticker. You specify the name and the symbol of a sticker of a digital sticker, and you say how many stickers you are going to create. So reusing for example, if you are going to create 100,000 or 20,000 or 5,000, and you define a price for people who want to buy the sticker, and you just create a new contract. And once the contract has been created, you get back his address here, and you basically then create the sticker ID, the token ID. And under this contract, you are just going to basically set the token ID, and then you will mint the token ID for the stickers. So this sticker will then belong to this of a collection. And when you are basically here creating the sticker, what's happening is that you are just specifying the type of sticker, and here it's actually not collection, it's NFT. And here in this case you just minting the total amount that exists. And yeah, that's about it. That's how you can use the different LSPs in combination to create different type of NFT collection. I hope you enjoy the video, and thank you.